Next we need to take, we're going to use these same formulas, but now our goal is actually to rearrange equations that are in polar form and write them in rectangular form, or vice versa. And the way you know you have an equation in polar form is, instead of x's and y's, it has r's, or it has theta, or it has both r and theta. And so what I'm going to show you here is a couple different tricks that are going to come up in equations that you'll see. You shouldn't see anything outside of these, but this is how we're going to tackle them. So our goal here is to replace what they've given you until you have it in the form you want. So here we have an r. My goal is to replace that r with stuff until I get just x's and y's and numbers left. And so in this case, I have number 5 is fine. I can leave that as 5. I've got this r over here, and helpfully I have an expression up here in my formulas where I can, this r equals this expression that has x's and y's in it. So I can actually just replace right off the bat, instead of r, I fill in that square root of x squared plus y squared equals 5. Technically at this point you can be done, unless, at some point as we get closer to the test, if we tell you it has to be in a specific form or if it says in the directions. The only other thing some people do, and especially if you check the back of the book, is we might square both sides. So then you'd have x squared plus y squared equals 25. And then it's a little bit nicer looking, and that ends up being the equation of a circle if you remember back to geometry days. So that would just be a little more familiar. But that's as far as we're going to need to go as far as this test for these. In letter B, we have something a little bit different. This time we have a theta. So my goal is to substitute, and in this case, I again can use my formulas up here. Here's theta. I'm going to replace theta with the other side. So I'm going to write inverse tangent of y over x equals pi over 4. And this is a case where technically we've gotten rid of the r and the theta, but this one we're going to need to clean up. We don't want to have inverse trig functions left. In fact, we want you to keep going until you get x's, y's, and numbers. And not angles like pi over 4, and not inverse tangents. The key to fixing this is if I just take the tangent of both sides. On the left side, the tangent of the inverse tangent, those just cancel each other out. And so I end up with y over x on the left. On the right, I end up with the tangent of pi over 4, but that's a unit circle value. So I end up with y over x equals the tangent of pi over 4 is root 2 over 2 divided by root 2 over 2, but that's just 1. The tangent of pi over 4 is just 1. And then I'm done. Okay, 2 more like this. These ones are a little bit different. Now in these 2 equations, in both of them you see both an r and we see a theta. And so a lot of times this is going to lean us toward using these over here when you have r and theta. The catch is my equation in letter C has cosecant, and if I'm going to substitute, I need either sine or cosine. So our first trick is not going to be any substituting. We're just going to rewrite. Cosecant I can write as 1 over sine. And so then our trick here is going to be, well, if I multiply by sine on both sides, multiply by the sine of theta, then on this side, 1 over sine theta times sine theta just becomes 1. So on the right side I have equals 3. On the left side, now I have sine theta and r multiplied together, so I'm going to be able to set this up and plug it in. So r times the sine of theta on the left is what I have, but r times the sine of theta is y. And so this equation, r equals cosecant theta, or 3 cosecant theta, it really ends up being in rectangular coordinates y equals 3, which is a horizontal line at 3. And last but not least, over on the right here, this time we don't have cosecant or secant or anything like that. We have r equals 6 times the cosine of theta. Well, in order to be able to use these substitutions from up above, I need not just cosine theta, but I need r times cosine theta. So our trick in this problem on the right is going to be to multiply by r over here, so I have the r cosine theta I want. But if I'm going to multiply by r on the left, I also need to multiply by r on the other side of the equation, so I don't mess everything up. So then now on the left, r times r here gives me r squared equals, I still have this negative 6, but now I have my r sine, whoops, not sine, r cosine theta. Well, now I need to do a little bit of substituting, but I'm actually sitting okay because here I have r squared, up here I have r squared, so I can replace that with this other side. So instead of r squared, I just write x squared plus y squared. And on this side, I have the r cosine theta I want, so this negative 6 stays here, but r cosine theta just equals x. So I'll end up with negative 6x. And at this point, I don't have any weird square roots or anything else that I need to change or get rid of, so I can actually stop right here.